Welcome you all. In this video, we are going to see the on case study on error detection on online programming platform. So using that, the case study is explained in terms of using the basis of compiler. So already you know that what is a compiler. The compiler is a translator, is translate our programming language, high level programming language into the assembly level language programming. So the phases of compilers contains the 6 phases like lexical analysis, syntax analysis, semantic analysis, and intermediate code generation, code optimization, and code generation. So using the phases of compiler, the case study on error detection on online programming platform is explained by our students Anirudh, Gokul, Ashwita, and Anish Kumar.
Okay, so in order to take the case study, the problem is when many students use an online programming platform, then while compiling, it faces several errors because of some performance or many students using at a time and everything. So here we are going to design a compiler system where the code is to be compiled and step-by-step execution of the code is to be written. So we are going to use the phases of compiler to design a compiler that interprets and that identifies the block of code, and generates the compilation process, and also it helps the code to be run.
Okay. Next is lexical analysis and the syntax analysis. The student basically write a C program like an hash includes studio.h in main, then inside the main block, in a is equal to 10, print percentage d a return 0. It is basically an C program. The compiler first performance lexical analysis. In this phase, the compiler reads the program characters program by character and convert into a token such as keywords, identifiers, operators, constants, and symbols. For example, int is a keyword, main would be an identifier, a is also an identifier, 10 is a constant, and equal to is an operator. After tokenization, the compiler performs syntax analysis. Here, it checks whether the program follows the grammar rules of a C language. In our program, the compiler detects that a semicolon after int a is equal to 10 is missing, since the syntax is incorrect. The compiler reports syntax error and asks the programmer to fix it before proceeding to the next steps. That's it.
So let us understand the semantic analysis and intermediate code generation. After correcting the syntax error, the programmer accidentally writes printf statement. So where the variable b has not been declared. Now the compiler enters the semantic analysis phase. In this phase, the compiler checks the meaning and logical correctness of the program. It verifies whether variable are declared before use, whether data types are compatible, and whether function calls are valid. So in our example, the compiler can't find the declaration of variable b, so it reports a semantic error. This helps the programmer identify logical mistakes that are detected during syntax checking. So the intermediate code generation is easier for the compiler to process and is independent of specific machine. It acts as a bridge between the source code and the final machine code. This representation also helps the compiler perform optimization more efficiently in the next stage.
So the next phase of the compiler is said to be the code optimization and code generation. In this, the compiler would be first performing the code optimization. In this phase, it would be improving the program by removing the unnecessary operations and simplifying the expressions. For example, if we are initializing a variable like x is equal to 5 plus 5, instead of assigning it as like that, it can be optimized as x is equal to 10. So this reduces the execution time and improves the performance. So next comes would be the code generation. In this phase, the optimized intermediate code is converted into the machine code or assembly language. The processor can directly execute this machine code. As a result, the program runs efficiently and produces the required output. So, after passing through all the compiler phases successfully, the corrected program would be uh, with the successful code. the compiler successfully generates the mission code and the output would be displayed as 10. So, I would like to conclude by saying that this case study shows how each compiler phase solves a specific problem. For example, lexical analysis identifies the token, syntax analysis detects the grammar errors, semantic analysis checks the logical correctness, intermediate code generation create an internal representation, code optimization would be improving the efficiency, code generation produces the executable mission code. Without these phases, the programmers would find it extremely difficult to identify the errors and execute the program correctly. Therefore, the phases of the compiler works together to ensure that every program is translated accurately. Thank you.